Welcome to the making of a real-time strategy game, Video 4. So far, we have developed a power transmission system, a truck logistical system. In the last video, we developed robot flocking, aggro, and a way to blow them up. I started this month without any clear objectives, so I decided to implement combat mechanics from my favorite real-time strategy games and see where it goes. Profiling was added to the game. The physics number that you see there is the amount of microseconds per second it takes to run the physics and the process, at least the ones in my own code. This code shows how to calculate microseconds in Godot, called the Godot.time.getTicks over the code to be profiled, accumulate this number in a ulong variable, and once a second, copy this to a variable for display. The engineering vehicle has a freeze effect. This is so far not used in the game. The first time a model is used in Godot, there can be a stutter as the material is loaded in the game. A special effects cache, in code effects cache, is used to preload models. Every special effect is now going to be created there, and that's where they're called. This also makes the code cleaner. The robots now can have shields. They are close to the final version in the game, except that one has a shader wave effect to make it more interesting. The shield is actually a special effects that follow the robots around. Performance testing of the physics is done using identical code in both C# and C++. It is found for every 70 milliseconds in C++. It takes 130 milliseconds in C#. This may seem bad, but it's actually not that bad. So C# is deemed quick enough in a general sense, so I wouldn't have to re-implement things in C++. And if I would need to run the physics quicker, it would actually be easier to add more threads in C#. An ambulance model is created. Starting with the first model I made, the delivery truck, the quality of models has increased. A common video that everyone makes for YouTube is about how the first few models look in Blender versus what they could do a few weeks later. Let's take a look how the ambulance is made. I find using Blender is like modeling clay. I have previously used CAD programs that use precise dimensioning and tools, so it is a little bit different. We start with an object, then grow it to full size. It is then molded into shape using the beveling tool. Materials are then applied to give it its look. A dog that is later used in this video is also made in Blender. To start with that, a side profile is obtained from Wikipedia. A two-dimensional quad is made and lined up with the picture. The edge of the quad is constantly extruded to be placed over the shape of the dog profile. The quad is then extruded to give it volume. Several knife cuts are performed and then shaped to give it a circular shape. The geometry is then mirrored around the axis so that it is in both sides. Legs and ears are extruded and material is applied. These two models took around 40 minutes of time to make, but have errors and the real models would take longer. There are much better video tutorials on YouTube of how you do that, so if you want to learn, I would go there. The ambulance can now reactivate disabled buildings by shocking them back to life. All of the laser weapons have been produced at this point. The cannon tank has been created. This version of the cannon tank has to aim directly at a robot, and the cannonball will actually home in on that robot. The robots now have a healer and a firefighter. All debuffs, such as fire and slow, are considered to be fires and rendered as such as particle effects. Code-wise, there is a fire effects class that contains all the code required for the fire. For each different fire effects, only the particle effects has to be made and loaded in. Otherwise, the code is the same. Three new engineering abilities are created. A new decoy truck that has damage return in the form of fire, a decoy truck that has bomb and explodes, and a dog that the robots run away from. The matchstick decoy tank fire effect is taken from a tutorial on fireworks. Just search it on YouTube to find it. A new cannonball has been created that ping-pongs. It homes in on the nearest robot within an angle. The effect is reused for the artillery. The robots have a cape type that has a long-range teleport. Also now, robots can teleport over small obstacles. Unlike most RTS games, player vehicles do not get destroyed, just disabled. So the robots teleporting over them solves pathing issues. Multi-meshes have been added to the game, but improperly in the robot generator class. It contains a multi-mesh for each robot type. A laser wall has been added that puts the robots on fire for crossing it. It has synergy with the dog that pushes robots into it. The multi-meshes in Robot Generate are implemented wrong. See, with multi-meshes, you can decide on an individual color for each robot. Instead, I have 3 multi-meshes for 3 colors. Oh well, it's a start. The robot generator also calls the physics and process for all the robots. It is found that removing robots from the game tree leads to a reduction of processing. When a new robot is created, a call from GP helper from only code new RTS items is used. This function uses a different instantiation that does not use Godot calls, and the robot is only added to the RTS model list and not the game tree. The artillery now has a napalm shell. The artillery can only fire one shell type at a time at this point. A new power plant has been created, the geothermal power plant, that has to be placed on a geothermal spring. This was inspired by Tropico, which has wind power. In that game, as soon as wind power is available, that is all I would go with, because after you place that, you do not need to maintain it with additional resources. In Tropico, one thing I didn't like was the logistical system, and when you have a power plant, I would often run out of that resource and then the power would shut off. However, in Tropico, you'd be able to create wind power in nearly unlimited quantity, so this would imbalance the game. So it was required to only be placed when allowed for in the map. So geothermal made sense, as it does not require additional resources, and it can only be placed where intended. We now have additional fire effects for freeze, etc. A new decoy truck has been added that has the plague. It spreads from robot to robot. It is inspired by a forest fire or percolation simulation that it did years ago. After catching a plague, the robot then becomes immune to that specific one. However, each decoy has its own plague. The RTS debuff class is created for all the debuffs. The dictionary stores each plague for each robot so it could be registered as immune. The class has code to spread the plague. It also has code to clear the debuff in time. New to the engineering vehicle is action buttons that allow it to visually use multiple abilities. It is later decided to use this for all the vehicles and the buildings. The engineering vehicle also has a flying goose that draws aggro to have the robots chase it into the laser wall, of course. Each engineering action has a function call. Later on, there's only one with the action type. The type of button is stored in the time button class, which has an enumeration with all the types that correspond to an overlay for each type. Similarly, the RTS engine contains an enumeration for each robot type. Both the robot enumeration and button enumeration are replaced with an inventory class that contain all the type enumerations of the game and can automatically load the textures. In hindsight, it seems obvious, and it should have been done this way the first time. The button timer is created by scaling the yellow overlay to full size when just pressed and to 0 when ready. Everything gets buttons now. How nice. The cannonball now fires on a target on the ground versus at a robot. But there is still no inventory system, just a lot of copy and paste. The cannonball has new types, including area effect, and a shotgun that isn't quite implemented correctly. The engineering vehicle now has Confuse that overrides aggro robots to do a random walk, and Rock'em robots, which cause them to fight each other. Neither of these two are in the game, as with the goose, dog, or laser wall, since the game doesn't really have a place for them right now. I might add them back in the future. I started this month without knowing what mechanics to do, so I studied other games, such as Warcraft 3, and realized they all have a variation of some basic mechanics, such as basic damage, like the intro laser, extra damage, like the fire laser, area effect damage, I have that, slow, yep, stun, summoning, control spells, debuffs, helper spells, such as healing and firefighting. Now, there's some things from those games that are very common, like counter damage types. You have different damages, different armors. I didn't want too much of this. In this game, the players are always range units, the robots are always melee units, and there's only one real damage type. I do have shields and the anti-shield gun, and I suppose that is in this category. I have also considered auras for both the player and the robots, but so far I haven't found a reason to implement them. I implemented what I thought would make sense in the game. I have enough extra abilities for 1 to 2 more control style units, but so far I haven't found a reason to add it. I also improved the code, such as adding the multi-mesh renderer and the action button system, both of which desperately need an inventory system. I suppose the best way to explain what happened this month is that I implemented gameplay mechanics and then, and only then, I improved the code to make it work. I'm not sure if this is the correct order of development. In fact, I'm pretty sure it isn't. But everything worked out in the end. I suppose this is the downside of working on the engine and the mechanics at the same time. Well, thanks for watching.